All right, first talker today, Chris Paget, and it's Extreme Range RFID. Let's give him a big hand here.
Thank you. Actually, let's see if I can use one of these mics. That's a little better. Can everyone hear me? Can everybody hear me? Yeah. There we go. Okay. All right. A couple of notes about privacy and safety just before I get going here. There is only one type of RFID tag that I'm reading in this demonstration, and that's EPC Generation 2. That's the tags that were handed out at the door. If you have other RFID tags on you and you're worried about them being read, sit on them. Your ass shields them really, really well. The tags that were handed out for the demo, they've all got unique serial numbers on them, so feel free to assume that I'm tracking every single one of you. Throw them away when the talk's done. Unlike the tags that the federal government issues, you can throw mine away. One quick point about RF safety. There isn't much power coming out of these antennas. There's about 3 watts coming out of this one, and this is receive only. So as long as you're like 2 feet away from it, you're perfectly safe. So don't touch, but yeah. The power amp's not even on yet. You'll see when I turn it on. So okay. So, what is EPC Generation 2? It's electronic product code compared to a universal product code. That's a barcode. EPC is effectively an RFID barcode. It's a 96-bit ID number typically. You can get other size tags. They go from 64-bit up to 128-bit. It's passively powered, so all of the energy that's running those tags and letting them switch on and transmit their IDs, it's coming out of this antenna and out of this power amplifier. So I am powering those tags. Works in the 900 megahertz ISM band, so 902 to 928. There is no security. There is Barbie doll security in that they have these kill codes and these lock codes, and if you send the kill code, then the tag will disable itself. If you send the lock code, then the tag will lock itself so that you can't change the ID number. Only problem is both of these codes are sent over the air in plain text with about a watt of RF. So you can just sniff these things off the air from several miles away. It's pathetic, it really is. So no security, no access control. This is the tag that's used in the US passport card. If anyone has one of those, a little card that gets you around North America. Anyone has an enhanced driver's license, it's the same RFID tag in there. It's also the same RFID tag that Walmart used for stock control. They've been using it for pallet level tagging for quite some time, and they're now going to be deploying to every single item. At least that's the plan. So how is this different from traditional RFID? Well, traditional RFID is an inductive system. You have a coil of wire in the reader, you have a coil of wire in the tag, the two couple together with a magnetic field. And each side of that gets to modulate that field and transmit data to the other one. So because it's a magnetic field, we've got an inverse cube law on field strength, which means that the available power drops off as the 6th power of range. So very, very sharp drop off in available power for the tag. Extremely difficult to power these things at long distance. EPC Gen 2, on the other hand, it's much more accurate to think of these tags that you're all holding as radar IFF transponders. So the radar systems that identify friend or foe, that's basically what these things are doing. So you've got a little radio receiver in there that charges up and powers the tag, and then upon being interrogated by the reader, the tag will modulate its coefficient of reflectivity. So you can think of that if there was an aircraft. As the aircraft tips towards the radar tower, exposes more of its wing